Well, welcome to today's show, and we have a fascinating guest with us today, Richard Lee, the Chief Executive Officer of Advanced Material Development, Inc. And Richard, it's a pleasure to have you here.
Thanks for having me, Jay.
Right. So to kick things off, would you go ahead and tell us who you are and what your journey's been like?
Yeah, so I'm a lad from the West Country of England, and moved to London like Dick Whittington to make my fortune, and ended up having to come to Austin really to try and fulfill that. Now I've been I guess an entrepreneur since my mid-20s. I've had a number of different technology, media type businesses, and I've always enjoyed, the ride of developing the product and developing the sales story and taking something to market, trying to disrupt things a little bit, or help those that are trying to disrupt industries and technology areas. And I've found myself, with over the years, many scars from those businesses. Some have done well, some have not. And finding my way into this new business was an absolute joy, and has been I guess, the most exciting of all of those companies that I've put together. Such exciting technology and exciting industries to integrate into, not least the defense community, particularly the defense community in the United States, and with our our bases in DC and primarily Austin.
Well, and with that background information, I've just got to ask, because when I first met you, your passion and the maturity and application of your technology just immediately hooked me. And so what was the core problem or opportunity that you identified that said, hey, we need to build this company, we need to bring this technology, and we need to get into the United States?
Yeah. Well, firstly, I hadn't thought about the United States. That's something that really came a few years ago after we'd been developing technology for a while. But it's the start of the journey was a conference I was at, helping a great friend of mine, Alan Dalton, who's a professor at the University of Sussex and now a chief science officer and founder in one of the co-founders, alongside my brother and I at Advanced Material Development. I was invited to this conference to help academics and researchers to help tell their stories. What is it about their technology was important, not just about the deep science behind it, but why should commerce care? And that was a fascinating opportunity for me. But through that, I got to hear Alan and others of his peers talk about nanomaterial technologies, and I was hooked that during that conference. And the problem, as I saw it, was here are some incredibly fascinating folk with incredible technologies, but when you ask them, where is it going? How do you get that into industry? That's kind of where the conversation sort of fell. And so after chatting to Alan, and saying how interested I was in some of particularly the environmental capabilities that I saw on some of this nanomaterial technologies, how could we go about developing a business that could own the IP and actually take this technology and these other, wonderful thoughts that he had in his head to market? And that was in, I think, June 2017, and within a month we'd got together with my big brother John and thought about how we structure a business like that. And John had always helped me in the past with putting businesses together, and this time we sort of decided that he should come in and join that one. So we were away, and within 9-12 months of that, we had raised our seed capital and launched the business, and we were away to we thought actually the key product of the business would actually be making graphene, but it turns out that is not the key product of the business. The key product of the business is actually processing those nanomaterials and turning them into capabilities.
Oh, interesting. So I'd like to look at the personal side first and then come back to the professional, if that's okay with you. What is it like actually working with your brother this time versus you'd said he'd been in an advisory role before?
It's been wonderful. And all listeners will know that sometimes there's friction with siblings, and some of those, but the closeness and the ability to be able to talk honestly with each other and really get down to the nitty gritty and not be worried about who upsets who has been a fantastic boon in the development of the business. So it's been great. John's strengths with his finance and banking background, being able to go out and talk to markets and people about raising money to fund the business, with my strengths really, which was all about being able to see what a product should be, see the gap in the marketplace, and be able to come up with a sales story to get that product to market. That combination of skills, surrounding ourselves with obviously with the great scientists that we have, and the backroom staff, biz dev guys, has enabled us to strike forward boldly.
Oh, and I can't wait to hear more about your product as we're having this discussion and as we get a chance to meet at the Association of United States Army's National Convention in 2 weeks.
Mm-hmm.
So, with that partnership between you and your brother John, what drove the expansion from your core company in the United Kingdom to the presence of the United States and you being here in Austin?
Yeah, so I think that we, early on, I think 2018, we started speaking to the defense community about what we were doing, and very quickly started working, particularly with the US Army, developing our radar absorbing materials. We started developing structural health monitoring capability and talking to the defense industries about how these could be useful for them. So the capabilities we have in defense can be used for developing products in non-defense. So a good example of that is, the development of conductive inks that we use for our structural health monitoring sensors. That same technology can be used in RFID. So being able to replace aluminum in RFID packaging, if you like, the antenna in RFID tags for packaging. And there's many cases of these. 7 or 8 of these key capabilities that we have in defense have led to non-defense product development and partnerships with industry. So whilst I was very focused on developing the defense side of the business, John was very focused on the non-defense side of the business. So still looking at industrial applications and life science applications as well, which is something very dear to the company as well. But my interest and love was just on the defense side of the business, wanting to develop things to protect warfighters. And then, after 4 or 5 years of funding these capabilities, getting them, through the TRL levels, working particularly with the DoD. We have worked with the Ministry of Defence in the UK as well, but particularly with the DoD. It became apparent that, of course, the biggest opportunity for those technologies was to get them over to the States as soon as possible. So that realization was gradual, but I think we made that decision about 3 years ago. That's what we needed to do. And it took us a while to make that happen. I wish I'd have got here sooner. As they say, I got here as fast as I could. But I'm here now, and Professor Dalton Allen is here as well. And we are incredibly excited about the opportunity ahead of us here.
Oh, and we're excited to have you here in Texas and also up in Virginia, where you can bring your advanced technology to really help the U.S. forces with protecting our forces, our facilities, our equipment, and everything else. So with that application in both commercial and defense environments, what is the current state of AMDNano's mission? What do you see as that core purpose of your company?
I think we're material scientists. Okay, we're not engineers, we're not manufacturers. So our job here is to identify, is to work with the Department of Defense and the defense industry to find out where the capability gaps are that can be filled by nanomaterial engineered solutions. We can provide the materials for that. So we're not going to build a drone. We're not going to develop an entire system for that drone. But what we are going to be able to do is develop a coating that will help shield it, hide it, and protect its structural integrity in some ways. We're going to be able to provide shielding capabilities to protect vehicles from internal, EMI challenges, these sorts of things. And it could be that we end up being mass manufacturers of these materials that we make, or we license them to those companies that have been doing this at scale for years, providing these sorts of materials to the Department of Defense for years. So really, we're about licensing our material solutions to industry and then going off and finding the next capability gap and engineering the next solution.
And thank you for that differentiation point too, about the fact that you can protect the structural integrity of a platform or an unmanned aerial system as much as you can protect it from detection or effects on a battlefield or an electromagnetic environment, something like that. So for those of folks who are listening right now who are going to come hear you talk, what is the core elements of the technologies you describe? In layman's terms, the nanotechnologies, the liquid processing, and things like that. What does that entail?
So, nanomaterials are, they describe materials that are on the atomic scale, if you like, 1 to 100 nanometers thick. If you imagine that there's hundreds of these different nanomaterials that we can work with. We focus on graphene and boron nitride and molybdenum sulfide and these sorts of things. But if we think about graphene for a moment, and that's one that most people and most of your audience will have heard of. If you imagine there are, let's take graphite. Graphite is a crystal, and imagine it being a book. We can peel off the layers of that book, page by page, if you like, sheet by sheet, and that's what people call graphene. Okay, so it's single layer structure that if you build it up in lots and lots of layers, it's graphite. Right, so you're taking down each layer of the book. It's incredibly thin. Like I said, it's on the atomic scale. But if you imagine the graphite has fantastic electrical properties that we want to capture. But when we actually put those into, imagine taking that sheet of graphene, those electrical properties are magnified enormously because we have something with a huge surface area, so we can get to the electrical properties straight away, and you have that electrical properties against a ratio of weight and size that is significantly different than when it's in that crystal form. And then if we're able to then control the number of layers that we want to get the electrical performance we need, and then disperse it into a liquid. We use water. A lot of companies will be based on solvents, but we disperse everything in water. Then we can print it. We can paint it. We can soak it into fibers. We can put it into composites. So these nanomaterials come from bigger structures. We're breaking them down into their layers and then building them up again like Lego to get the properties we want, and then putting them into systems so those electrical properties come through into the system.
Oh, okay, thank you so much for that explanation. So that's how you can get wide-ranging outcomes from things like radar absorption to infrared camouflage, or even how you can monitor, I would imagine, micro cracks and things like that inside of the structural, because you can control the electrical flow or the signal through those materials.
Correct. It's sometimes I try and explain these things in a bit too much detail than I ought to, because I find myself lacking. But if we think about the radar absorbing properties, so we can make very, very thin coatings or very thin films, or soak our materials into fabrics, and the radar energy coming in and hitting hitting that system is absorbed and dissipated at heat throughout the coating or the fabric, etc. So less energy being reflected back to source. So we've worked on that technology with the US Army for I think seven years now, and that has, applications, if you like, on UAVs, on large shelters, on anything that you really want to hide from radar. We are pretty, substrate agnostic. We can put this into pretty much anything or onto pretty much anything. And particular areas that we are interested in at the moment, I keep saying it, UAVs, drones in general, missiles, and shelters, things that we want to really be able to hide from radar. Then with the infrared side of it as well, we are particularly excited about our capability to be able to attenuate the absorption of IR energy, basically. So we're able to actively control the reflectivity or thermal emissivity of our coatings, so that, a tank that is being quite easily identified or tracked at the moment on the battlefield, and obviously Russia's war against Ukraine has taught us this, that these hundreds of millions or multi-million pound combat vehicles can be targeted by cheap drones and in some cases destroyed by those cheap drones. So if we're able to help those systems blend into the background or obfuscate, to defeat these sensor systems and algorithms that are being used to hunt, then we can protect the warfighter and enable the platform to get to do its job efficiently.
That is really exciting to hear, Richard. One of our challenges as we were conducting experimentation during my last job in Army Futures Command was the fact that we live in a world of ubiquitous sensors. Everything from a cell phone that can geolocate something on the ground, report that information as part of the metadata on the picture, to all the sensors that are flying, the breadth of EO, IR, and everything else. So that ability to reduce your visibility in a world where you can be seen otherwise, that's got some profound operational impact. And I'm really excited to hear how that will apply. And speaking of, as I understand it, I saw an announcement recently that AMDNano received a patent. And is that something you can share with us?
Yeah, sure. So the patent had been provided already outside of the US, and this is our key technology for our liquid processing. So our liquid processing IP, if you like, enables us to develop these coatings with various nanomaterials, with the layers we need, the aspect ratio of the materials as we need them to be, in a very, very controlled way. But the other significant point of it is that we can do this at scale and at very low cost. A lot of, there's two things that were wrong, I think, in the early days of graphene, is that A, everyone thought it was going to be able to do everything, and B, it was very, very expensive. So now we know that it can't do everything, but we've identified, how we can work with graphene and other nanomaterials now to have real capabilities that have real impact, and we can do it in a reproducible and cost-effective way. So I think that is the real point of difference with advanced material development, both the UK non-defense capabilities, but the defense capability here. I often find myself in discussion with companies, and they say, well, how much will this cost us? And I say, well, the cost of the materials is not the limiting factor here. It's there's a licensing discussion you need to have with us, and it's not about how much it costs us to make the materials. It's about how much value we will offer to you and for your platforms. If we can help those platforms survive longer so that they can do their do their job, then that's how we need to work out what the value of our contribution.
Yeah. Richard, I really appreciate your time to have this discussion. I'm really excited to watch the continued development and deployment of your technology in both those commercial and defense applications. And very thankful that you and your brother made the decision for you to come on over to the States and for you to land in Austin with us as you grow your business here. That said, I'd like to give you the final word for any closing comments.
Yeah, so again, I have to say that we've been so warmly welcomed here by the defence community, yourself, included, Jay, and we're going to be building our defence business in Austin. Looking at some other potential places to develop capabilities, including up in College Station, and we want to build fast. We believe that we have technologies that can help protect the warfighter today. We need help. We need to meet more companies that want to work with us. We're also raising money. So if anyone's interested in what we're doing, I'm very happy to speak to your listeners about that as well.
Oh, great. Thank you. And if you could just tell us the best way to contact you, I'm assuming it's your website, and I'll put that in the comments as well.
Yeah, contact me through my email is probably the best way to do it, Jay. I think you've got my email address, richard at amdnano-usa.com. I'm very, very happy to talk to anyone that will listen.
Great. Richard, thanks so much for your time. That's all for today, and I hope everyone out there has a great rest of the day.
Cheers, Jay. Thank you.
Cheers.